welcome to another episode of the Minor Tweak, Major Impact podcast. In today's episode, we had the pleasure of speaking with Dr. Véronique Kiermer, who is the Chief Scientific Officer at PLOS, the Public Library of Science, where she oversees the editorial department and initiatives to promote open science. She trained as a molecular biologist at the University of Brussels and the University of California in San Francisco, and she also worked in the biotech industry in the Bay Area. Veronique started her career in publishing as the founding chief editor of Nature Methods, and she held several roles at Nature Publishing Group, including the publisher for Nature Protocols and executive director for the Nature Journals before moving to PLOS in 2015. In this episode, we're talking with Veronique about her experience with initiatives that encourage researchers to report method details, code, data, and more as part of their research output. And you will also get a sneak preview of an exciting new initiative of PLOS in partnership with Protocols.io that will be launched in early 2021. So let's jump right in. Veronique, I would like to welcome you to the Minor Tweak, Major Impact podcast.
Thanks for having me.
Veronique, to get started, can you please tell us a little bit about yourself, your background, and what you're currently working on?
Sure. I'm a molecular biologist by training. I have a PhD from the University of Brussels in Belgium. I did my postdoc at UCSF at the Gladstone Institute. And after my postdoc, I worked in the biotech industry for a few years in the San Francisco Bay Area. And then I made a big career move. I left the bench and I started working in publishing, where I've been ever since. And that's been more than 15 years. So my first job in publishing was the founding chief editor of Nature Methods. I then had several roles at Nature Publishing Group for a period of about 12 years, including 5 years as the executive editor for all the Nature journals. And then 5 years ago, I moved to PLOS, where I'm now the chief scientific officer. And there I oversee the editorial department, and with colleagues across the organization, really, I work on initiatives to promote open science. So we try to encourage authors to share openly not only their articles, but also their data, their code, their methodologies, etc. And then we also try to make our own processes more transparent. So, for example, we facilitate the posting of preprints, publication of peer review history, and we encourage pre-registrations where it makes sense.
Great. And you already mentioned that you chose a career path really from working as a molecular biologist in academia to the biotech industry and then finally into the publishing world. Can you please tell us a little bit more about that decision and what really motivated you to follow that career path?
I loved working in industry. I loved the discipline of the concrete outcomes that you're bound by in industry. And I loved how we worked as a cross-functional team where everyone brings specific expertise and everyone's contributions is essential. But on the flip side of that, you have much less freedom in industry than in academia. And I had this vision of myself becoming extremely specialized in ways that I felt were too constraining for me. So I wanted a job where my contribution could make a difference, but where I would keep a broad perspective scientifically and I would keep learning. And it was just pure luck that Nature was launching this new journal at the time called Nature Methods, and that would allow me to do just that, to try to make a difference and to keep learning. So I've never looked back.
Very cool. And that also leads into my next question. So as you mentioned, you were the founding editor of Nature Methods, and you also helped to set up Nature's Protocol Exchange. Can you please tell us a little bit really about the history, motivations, and what were, if there were any challenges for launching those initiatives?
Yeah. So before the journal even existed, the concept of Nature Methods was immediately attractive to me because I thought it could be a game changer and it could make an impact in an important way. That is to give full credit to people who develop methods. But there was a lot of skepticism about it, including within Nature Publishing Group at the time. At the time, the methods papers were still considered a bit dismissively. It wasn't unusual to submit a methods paper to a good journal and then to be told, quote unquote, it was just a methods paper. And so for me, launching Nature Methods was an opportunity to try to change that. But there were a lot of people who thought that the journal would somehow devaluate the brand, that it wouldn't be possible to fill a successful Nature journals with only methods. And so that was a challenge, but I had the enormous privilege of being able to recruit my own team, and it was a fantastic team of editors. I really selected people who shared my passion for methods development. And we reached out to scientists, to all the labs where we knew there were a lot of papers with really cool methodological approaches. And even if they weren't publishing their methods at the time, we knew they were using and developing really exciting methods. And they were convinced too. And so in the end, I think it really worked out. That was the challenges we had with Nature Methods. For protocol exchange, that was slightly different. I became involved with Nature Protocols, the parent journal, a few years after it had launched. And at that time, it bothered me that we were publishing only authoritative versions of protocols. And I thought we were missing a trick, and that the scientific community would benefit from seeing all the versions of a protocol with all the tweaks that people bring to protocols to make them work better in one system or another. And that's how the idea of protocol exchange was born. And the challenges there were more functional and technological, in the sense that we needed to make a platform suitable for presenting and using protocols in the lab. There was a lot of functionality that I wished for, but we couldn't really develop it. And so these were more technological challenges, I would say. And this is also why I was so impressed when I discovered protocols.io a few years later, because it really had all the functionality I had dreamed for at the time.
That's very great and very inspiring. Another initiative that I think you were involved with last year in 2019 is the Materials Design Analysis Reporting, or MDAR Checklist, which is a minimum standards reporting checklist for the life sciences. Can you please tell us a little bit more about what that initiative is and really how it came about?
Yes. So MDAR, as we call it, is a guideline for what should be minimally reported in a journal article across these rubrics. So materials, designs of experiments, analysis, and then a generic sort of reporting category. And it's designed for the life sciences. And in particular, it applies to basic research, so laboratory-based type of studies. And it's come together as a collaboration, really, between editors across 6 publishers and other experts. And then throughout the development of these guidelines, really, it's been a very large community-wide consultation with more journals as well as experts in reporting and experts who had put together other types of guidelines. So what's important to think of about MDAR is that there are already many specialist reporting guidelines. For example, you have Consort for randomized controlled trials and other clinical research guidelines that are maintained by the Equator Network. You have the ARRIVE guidelines for animal research, and then you have minimal information about specific types of experiments that are cataloged on fair sharing. So each of these existing guidelines is very important, and MDAR really is in no way a replacement for these guidelines. But the group that put together MDAR intended it as a generalist foundation, if you wish, something that can pragmatically be applied across a wide range of journals and specialties. And then it can be enhanced by specialist guidelines in disciplines where these guidelines make sense. So there were really 2 motivations when we started. The first was to help researchers be reminded of what they need to minimally report, regardless of where they will publish their research. So that can be helpful not only at the time of writing the paper, but really and most importantly at the time of planning and conducting the experiment. And then the second motivation was to help as many journals as possible adopt similar reporting recommendations or requirements. And we reasoned that if there was an harmonized set of basic requirements, it has a better chance of getting traction with journals and with researchers as well. So the group that put MDAR together was a small group of editors and reporting experts. The editors all had experience with implementing either checklists or reporting guidelines, whether they were sort of author-facing checklists like, the Nature and the Cell Press journals have, or checklists that are used in internal processes. And that was the case at PLOS, as well as Science, eLife, and several Wiley journals. And so the other experts that participated, that joined the group, were Malcolm MacLeod, who is a researcher who has studied quality of reporting and the effectiveness of interventions such as checklists and other interventions. And also David Meller from the Center for Open Science, who has helped develop and maintain the top guidelines, which are known as the Transparency and Openness Promotion Guidelines. And so the Center for Open Science will be the steward of MDAR going forward, in the sense that they will make sure that it is maintained openly as a community resource. And another thing important to think of about MDAR is that the group wanted to take a pragmatic approach, really, sort of balancing the ideal reporting with the reality, and the reality including sort of the readiness of the scientific community to report certain things, as well as the practicality of implementation for journals. And so several things during the development of MDAR were very important for that. First, we consulted very widely. As I mentioned, there were public meetings, and we also sought feedback from experts. And then we also ran a pilot, actually, in which one of the instruments of the MDAR guideline, it's a checklist that covers the basic recommendation, was tested in 13 journals. And in these 13 journals, overall, more than 200 researchers actually used the checklist to complete their paper. And based on this, we were able to establish that both journals and researchers found the checklist helpful. And then we also got very important feedback that we iterated upon. And then finally, what's also important is that the MDAR framework basically has two levels for each element. One is a minimal requirement, and one is an aspirational best practice. And we know that journals and researchers in different disciplines will be at different levels. Some are already using the best practice, for example, and we hope that over time MDAR will evolve with some of the best practices becoming minimal requirement. So we will release the final material before the end of the year, and it will be available on the Center for Open Science website. And we really hope that we're going to get broad adoption, and that MDAR will be a community resource that continues to evolve over time.
Okay, great. And once it's released, I'll be sure to add a link in the show notes. So if you're listening to this podcast afterwards, you'll be able to find it there.
Great. Thank you.
Cool. So we have already heard now a lot of great initiatives and things you've been working on, and it's very inspiring, all the things that you've been working on to really make research better and more reproducible. But I was wondering, what was really your personal motivation for working on these exciting projects to encourage researchers to report method details and share their code and data, etc., and all these things as part of their research output?
Over the years I've spent working in publishing, I've really become convinced that the principles of open science are really important. In my view, these principles are critical for several reasons. First, being more transparent and more open about the scientific process and about how scientific results are arrived at. I find this essential for scientists to really earn the trust of their colleagues, but also the trust of the general public. And we know that this is really essential, and today trust in science is ever so important. And so this is a big element. And secondly, it's also by sharing more transparently all the elements that go into a research process, it allows further collaboration. It allows true collaboration to accelerate science. It allows more people to start participating in the process because they have access to what others have done, because they can not repeat mistakes. And really, we can reduce the inefficiencies in the system of scientific research. And I think that allowing more people to participate and to benefit from that is incredibly important as well. So for me, the motivations are really around building trust, encouraging speed and access to more people. And I think these are really compelling principles to live by and to do science according to. And I feel that all these principles and these motivations have been thrown really in sharp relief by what we're experiencing now, living through a worldwide pandemic and trying to really rapidly arrive at solutions and having these solutions and the scientific process being trusted by the public.
And what do you think this year, 2020, like the pandemic, what do you think this entire year has really as an impact on the scientific community? Because I was actually very excited in the beginning. I think people were sharing things very fast, as you mentioned, and like openly. And I've never really seen that before. And it really made me excited. And I was wondering if there's any like maybe long-term effect or long-term impact that this year actually will have on the scientific community, if things will be changing after we're through this pandemic. What's your opinion on that?
I really hope so. And I think you're right. We've seen people sharing and collaborating in unprecedented ways, really conducting research at accelerated speed while, trying to really draw on the best practices, on the best expertise of the best teams. And I think that it's been really amazing to see that happen. And I think that a lot of people have realized that it's really important to share, to collaborate, to go fast. And I think because we had this urgency and this incredible motivation that everyone can get behind, it became very obvious that sharing and collaborating was really important. And so we've seen people being much more open about code, being more open about data. We've also seen examples of when data was not available that created a lot of problems and a lot of fits and starts. And I think that was a lesson for all of us. And so I really think that people sharing preprints and sharing code and sharing data has been encouraged and accelerated during the pandemic. And I really hope that once people have experienced that, they will keep that as a long-lasting effect, and that we've shown that science can be done faster, more effectively, more efficiently. I can't imagine that we won't keep the lessons from that. And I think we will carry that forward in the future. And this is really exciting.
Yes, that would be great. And I agree, it's very exciting. And I think if all the researchers continue to share their information and data and everything as they did during the pandemic, I think, science will move a lot faster, which would be really exciting to see. So my next question is a question that I always ask on this podcast. When you're still at the bench, I know right now you're not, did you ever experience what we call a minor tweak, major impact moment? And that could mean different things. Did you ever yourself work with a method that worked great and all of a sudden it stopped working? Or did you try to work with a method that somebody else got to work, but for you, for some reason it didn't work? Or did you ever experience anything like that before?
Of course. Yes, all of the above. My experience at the bench is a good few years back now, but certainly I went through all that. And actually, when I think of that, what comes to mind is it's my experience in industry, because funnily enough, when I was working in biotech, I was actively trying to avoid these moments as much as possible of minor tweak, major impact. And the reason for that is my team was developing assays for the quality control of a new biological therapeutic. So it was a gene therapy vector that contained a gene that was deficient in kids with an X chromosome linked inherited disease. This gene therapy vector is a biological reagent. And so the quality of such a reagent is really tricky to control and to characterize. And so we designed a battery of assays, but the goal was to make the assays as reproducible as possible and to characterize the margin of errors of the assays very carefully. So then when you saw a difference in a measurement, you could attribute the difference to a meaningful difference about the product you were testing and not about the test itself. And so we spent weeks trying to identify where the variability in the assays was coming from and trying to control it. So for some assays, it was around temperature, for example. So we had the incubators had to be calibrated every few days. For other assays, it was about the culture medium. We bought an entire stock of serum for the culture to always use the same one. For me, it was really an important experience because it made me aware very acutely of the inherent variability of the biological systems and also of the tools we use to study these biological systems. And so it was a very good learning experience and it was very humbling.
Great. Thank you for sharing that story. And now shifting gears a little bit, in 2017, PLOS and Protocols.io announced a partnership really to improve the reporting and reproducibility of published methods. And now actually for 2021, we're looking forward to a new initiative that we're all very excited about. And I was wondering if you could tell us a little bit more about what PLOS has planned for 2021 in partnership with Protocols.io.
Yes, it's a really exciting time for us. The partnership that PLOS and Protocols.io had in 2017 basically made it possible for PLOS authors to write their method sections differently and to link directly from the article to the step-by-step protocols that they had in Protocols.io. And that was really meant to improve reproducibility and reporting. And so what we have learned since then is that users of the Protocols.io platform really like it and really like the functionality that it offers. And some of them also would like their methods to be validated, to be given, some sort of seal of approval, if you wish. And so the new partnership will allow researchers to deposit a protocol on protocols.io and then to give it a bit more context and to have it peer-reviewed at PLOS. So the published peer-reviewed protocols articles will be published in PLOS One, and they will link to the protocols in protocols.io. Not only will we have a fixed version of that protocol associated with the article, but also on protocols.io, the protocols can continue to evolve and to have, subsequent versions with improvements, all these tweaks, notes from users, etc. And so I'm really excited about this because I think it's a partnership that brings together the strengths of both organizations. We have a common goal, which is to make methods more accessible and more reproducible. And I think we're using in this partnership the respective strengths of both organizations. We have the wonderful presentation of protocols on the protocols.io platform and the interactions there around the discussions and improvements that are provided by a very vibrant community of users. And then we have the peer review expertise and infrastructure that we have at PLOS. And I hope that this will be a new way for researchers to share their methods and to receive due credit for that, and including credit for all these tweaks with major impacts that we're talking about.
Yes, I agree. And I'm very excited and looking forward for this to start. So be sure to stay tuned for 2021, what we have coming for you. And so now my last question always on this show is, if you were allowed to make a wish for a tool that would make the life of, usually I say researchers, easier and more efficient, what would that be? But I think you can also answer it for, if you were allowed to make a wish for a tool that would make the life of maybe publishers easier and the work more efficient, what would that be? And this is our fun question, and any answers are allowed.
I think I'd like some sort of AI tool that makes it really easy for authors of scientific papers to report everything they need to report. I think in my experience, it's not that people don't want to report key details. It's just that they're not trained to do so, they're not prepared to do so, and it takes a lot of effort. In the publishing industry, we've been tackling this with checklists and policies and with editors who check for compliance with these, and we go back and forth with the authors. And I know it can be very tedious for authors, it can be very frustrating, and sometimes it's confusing because researchers don't know where or how they can share their code, their data, their methodological details, and so on. And so instead, I think if we had a tool that would make it super easy, a positive experience, something that would give you guidance on how to do it well, it could really be a game changer. And I think we would all benefit from that.
That's a great idea. And I think this is actually a lot more realistic and doable than some of the other answers we had for this question. So hopefully someday we will have that tool. Is there anything else that you would like to share with our listeners today before we wrap up?
I'd say if you're listening to Protocols.io podcast, I suppose you are probably already sharing your methods on this platform. And I just want to say what you do is important. I think it makes your work more credible. It helps other researchers save time. And so I just want to say thank you and keep up the good work.
Great. Veronique, thank you so much for being with us today and sharing your story and insights on the Minor Tweak Major Impact podcast.
Thank you for having me.
This is your host, Anita, and we look forward to being with you for our next episode.
This program was produced by H Media. We'll see you soon.